Good morning and welcome to what is our last webinar of 2020. This time it's all about controlling ground, water and gas, how to get synergy. I'm your host, Andy Ferguson, and today I am pleased to welcome Patrick Flood from Utah. Morning, Patrick.
Good morning, Andy.
Now, for most of you, for most of our regular listeners, you'll be very used to what I'm about to say next, but for all those that are regular, a big hello to you. If you are a new listener, then a big welcome to you, and I hope you get quite a lot of learning from today. I just also want to say an extra special welcome to some of our international listeners. I believe we've got international listeners on from Africa, New Zealand, Australia, and in some parts of America. Now, I don't know what time it is over your way, whatever time it is. I imagine it might be daft o'clock, but a big welcome to you. Now, for those that over the course of the webinar that want to pose any kind of questions or say any comments or even just say hello, first place I would like to point you to is to the chat facility. Now, if you're on a desktop, that'll be just to the left or the right of you. There is a chat functionality there, chat box. Just type in whatever you want to type in there, say hello, any kind of questions, and we will get them. Similar, if you are on a mobile device, all you need to do is just basically pull up your screen a little bit and you will see that chat functionality in there. Again, feel free to say hello to us, but there is other ways in which you can contact us. You can contact me via email. Just simply email me at andy@property-care.org with any questions that you might have. That's andy@property-care.org. Or alternatively, if you are socially savvy, and I know some of you are because you do it on a monthly basis, simply send your questions to me via social media, whatever your preferred choice is, either Twitter, LinkedIn, or Facebook. Just simply use the native apps on those platforms and look for the Property Care Association. Just a note in case of any crash issues might happen. It does happen. It is 9 o'clock, people turning on their PCs. If something does so happen, there should be a little button that pops up on your screen that effectively allows you to refresh. If you press that button, hopefully you should come back to us okay. And feel free for anyone that spots in the chat just to kind of throw any kind of assistance on there. Just to be updated, just in terms of conferences and PCA awards, many of you will be aware we were unable to run our conferences this year, but I just want to let you know that we are planning on announcing some PCA awards for this year coming up very, very soon. In fact, there's a blog story coming out about it tomorrow in the weekly newsletter. Just look out for it. And just some hot gossip for you guys as well. Now, I know they've got a lot of waterproofing guys on here, but this is more to do with our ground gas specialist. This is regarding the NVQ for the Diploma for the Verification of Ground Gas Protection Systems. By heck, that is some name. I think that needs to get changed. But anyway, off the back of us kind of going back and forth for the last 2 years, I'm now pleased to say that your qualification is now being recognised by CSCS, the Construction Safety Certificate Scheme, and I almost buggered that up and actually saying it out there. But if you want to know a little bit more, I am going to be touching base on it at the end of the webinar, but you can contact our training team for more information. Patrick, looking at the clock, we've got about 2 minutes to kind of go. How are you, good sir, this morning?
Yes, I'm all right, Andy, thank you. I think probably much like everybody else, quite sort of tired at the moment. Things are very busy. But yeah, I was listening to Rishi Sunak last night with the spending review, so semi-positive for the sectors moving forward. So yeah, feeling reasonably positive this morning, Andy.
Well, Patrick, many of our attendees would have spotted this when they went on to the thanks page. The cowboy hat. Tell us about the cowboy hat. Now, I know it's in your presentation as well, but the big cowboy, how did that come about?
Well, I mean, many of you might know this, but I'm actually a cowboy No, I think I'm just a big dafty, really. So it's just about being daft. I mean, I like to just have a bit of fun with things more than anything. So, and I think with anything in life, if you can take the mickey out of yourself a little bit, it can sometimes soften the approach, particularly for people who don't know me. It just helps soften that introduction, I think.
Well, do you know, Patrick, I'm a big fan of that. I like to do the same myself. I think my only note would be maybe don't go out doing some Olympic work or running with the hat on. That's all I would say. Sorry. Well, anyway, getting back onto a more serious note, because I can see that we are at that time, 9 o'clock. Wow. Controlling ground gases and water, how to get synergy. I have to say, big topic. Patrick, so how do we tackle the problem of both structural and below ground waterproofing? What conflicts actually exist between the different standards that are about there, and how do we best balance this off and balance the conflicts? I know these are massive questions, Patrick, and I know a lot of your peers are on here, so I tip my hat off to you on the challenge of it, and I suppose it's over to yourself, good sir.
Okay, thanks, Andy. Good morning again. I think I decided, given that this is probably the last presentation before Christmas as well, I would don some sort of festive shirt. So, Merry Christmas. As you will sort of come to appreciate, the approach is fairly laid back. I find that's the best way for learning. But help yourself to tea and coffee. Pants are completely optional with what we're doing here. And let's see if we can learn a little bit more about gas and waterproofing. I think there's a lot to cover. That there is a hell of a lot. And what we're going to try and do is I guess, scratch the surface in terms of some basic considerations. There's no way we're going to cover everything. Absolutely no way. So I think I was saying to Andy and James yesterday when they culled 30 slides out of this presentation because they didn't think we'd have enough time, which I agree with. There's perhaps going to be additional webinars required, focusing in on some of the more controversial or less understood aspects. But obviously the idea today is to look at how to measure, understand and balance the risk associated with structural waterproofing and ground gas protection. We're going to look at current guidance and some emerging guidance of relevance as well, and the relevance primarily to new builds. So we're going to touch slightly on retrospective, but the bulk of this guidance and approach to particularly gas protection is focused around new build construction. So hopefully today helps the listeners and the members of the PCA to be able to ask the right questions. So what I'm not trying to do, or what we're not trying to do here, is to give you in a 45-minute session all the answers. The idea is to raise awareness of things we should be looking at and arm you with the right questions to ask, so how to get that information more than anything. We're going to focus primarily, obviously, on the core principles of BS 8102 and BS 8485, which are probably the most two relevant guidance documents in this sector. And there's a slight nod or tip of the old ACUBRA to the Basement Information Centre, so TBIC, which is just about to publish, due in January 2021, a sort of guide to basements and ground gas and structural waterproofing. We had a comments review meeting on Monday this week, so there was a lot of feedback from industry for which we're very appreciative. So there is still a little bit of work to do on that, but we're still confident of getting that out in January. And then Syria about to publish as well, Syria C759, which is guidance around retrospective hazardous gas protection. So obviously there's quite a few members who I imagine be interested in that. And Syria themselves, as well as probably the PCA close to the time, will likely run a series of presentations focused around the retrospective aspect. So we're just going to touch on the Hackett report, and I think those of you who've been watching the news, obviously the Grenfell tower disaster, which is currently front and centre of a lot of the news programmes. But on the back of the Hackett report, on the back of Grenfell, Hackett commissioned this review of industry, so looking at safety practices. And it started to resonate. So it's like a ripple in a pond. It goes further out and out and out, and eventually it kind of encompassed the entire construction sector and the built environment. And what we kind of identified, or what was identified, during this process, was that there's some bad cultural issues in the construction industry related to this race to the bottom. So before we've even done anything on site, we're looking to save costs. So, and that doesn't really facilitate good practice. So what we need to do is kind of focus on changing and embracing the change, both in terms of current practice and through innovation. So looking in more detail at products that are coming to market, looking to improve our sustainable approach and objectives if we are to achieve these long-term quality and sustainable aims. And again, I think I feel a bit sorry for this chap at Celotex. So if you've been watching the news, so again, Celotex or Mark Roper, this chap has admitted to basically falsifying technical data sheets to fiddle test reports to make certain products look more suitable for application functions than they actually are. And I think although the consequences of failure were obviously pretty significant in the cladding sector. In the above ground gas sector in particular, we still, even with guidance changes in 2015 and 2019, we still see a lot of material supplied to market with good marketing information and statements of fact without any information, so any technical justifications or information to help engineers make an informed decision. And our job as manufacturers and suppliers is to give designers, engineers, architects, specifiers the relevant information to enable them to make the decision in terms of material suitability. So I think it's a fair point, and just helps us focus in on information, which is a theme that runs through today's session. So BS 8485 and BS 8102. So the Code of Practice for designing protective measures for methane and carbon dioxide, gas protective measures for new buildings, and the Code of Practice for protection of below ground structures from water in the ground. I find it quite amusing. I think, Andy, if you stick the poll up now, and I'll just carry on talking. So just a quick question for you all, just to see whether everyone's awake and alert at 9:07 in the morning. Which of these two documents do you feel takes precedent in this particular scenario? So if we're looking at waterproofing and gas proofing, BS 102, 8485, which takes precedent? Andy, are you running that poll?
Yeah.
That's it.
So if you look on your screen at the moment, it should either pop up for you, or if it's a mobile, you might need to pull it down a little bit. I'm just going to keep it on for about another 5 seconds or so.
Yeah, we don't need to wait for everyone. It's just general consensus of opinion, and I think one of the things we're doing in the 8102 revision at the minute is arguing around the title of the document. So here we are, I guess, nearly a month into it, and we still haven't agreed on what the title of the document is going to be. So,
well, I can tell you, 21% versus 78%.
Which is the favourable? Which is 78%? Which doc?
It's the BS 8485 2015 plus the A1 2019.
Yeah, no, I mean that's fair comment, but the reality is both documents should be considered in equal measure. So the secret answer number C, trick, haha. So just to see, we've got to consider all guidance in equal measures, but there's relevant sections in both which we should be drawing on. People will often talk about legal precedent in BS 8102 in specific reference to the 1999 Outwing case. And that's 21-year-old, although it serves as a good basis and a sound principle for what we shouldn't be doing. We also have some legal precedent around BSA 485. So there's the unfortunate case of Goldbridge, which is still under litigation, and they're fighting in the courts as to who is ultimately responsible, where they demolished a number of houses due to inadequate gas protection. And then we've got incidents of verifiers. So it's actually a project manager ended up in prison for falsifying a gas protection verification report. And then most recently, which was only a couple of months ago, we have a housing development in Bradford, which has been valued at zero because of failure to get appropriate sign-off on gas protective measures. And I know there are industry experts involved in a few of those cases still, doing back analysis, so looking retrospectively at gas protection. But both documents should be considered equal. So if we look at our appetite for risk, there's a common misconception that basement construction is high risk. Of course, there are additional challenges with constructing below ground, but not all basement construction is high risk. So there will be some instances where we can construct below ground level with relative low risk, both in terms of waterproofing protection and with regards to gas proofing. But what we have in our industry is everything is last minute. So the amount of phone calls I get, I've got 3 waiting for me when I come off this presentation, where we've got people on site and they're supposed to be installing gas membranes and they've got lift pits and they don't know what they're doing. It's like, well, how have you got to the point where spades are in the ground, concrete is being cast, and we haven't considered the forms of defence for the structure? It's bizarre, but it does happen, and it happens more often these days. I don't know why. We often talk about in our office the last sort of 3 to 4 years in particular. Everything is last minute. Everything is rush. The amount of planning is out the window at the minute. Forecasting when people need materials, it's just very, very difficult to get a handle on programs of works at the minute, which is something I think we need to look at as an industry and look to change in general. So better planning will save ourselves a lot of pain and a lot of money by being better prepared. So that is what drives risk up a lot of the time as well. That rush. We end up having to compromise, and compromise is usually introducing additional risks. But to understand risk, first we have to understand, to reduce risk, first we have to understand it. And I know if any of my colleagues are watching this, they're going to be hanging their heads, because I'm constantly talking about this Dunning-Kruger effect in terms of the bathtub of knowledge. So when we do a little bit of training, everyone leaves the sessions feeling full of confidence, and they go out into the world preaching the message as though they know everything. And then over time, you realise perhaps what I learned in that 45-minute session wasn't everything, and we develop an understanding over time. And then only with lots of knowledge and experience, both in terms of practical and theoretical, do we get a good understanding of industry, but we also learn to appreciate our limitations, which is part of that experience and knowledge curve. So we know what we're good at and we know what we're not good at. And again, one thing I find hilarious about our industry, both in terms of manufacturing, environmental protection across multiple sectors, is we don't talk about our limitations. It's one of the things we don't do. We don't walk in, and I got embroiled in a LinkedIn 2 and 4 for a couple of months back, if anyone's that bothered about social media, where we were sort of actively discussing limitations of products, and I think a lot of other manufacturers around the world were horrified that I'd gone on there and talked about what our products didn't do. But that's what we should be doing. Like, don't use that product we supply in that application scenario. It's not fit for purpose. That's a significant understanding of limitation. As I said, it takes a lot of time to get to that point, and many people are prepared to take on more risk. Now, what you can find is there are sometimes commercial drivers around that, or as in the gas industry, there are 10 or so more very, very qualified and experienced professionals who understand those risks in a lot more detail than most, and they'd be prepared to take that on. We lost a little bit of transition feature actually when we uploaded the presentation to Webinar Jam, which I'm upset about, but this particular slide, I mean, I see it all the time, again, with our guys, with others in the industry. We'll get a drawing in. There'll be some lines on the drawing which indicate damp proofing, waterproofing, perhaps a note saying waterproof concrete, but there's usually a big stamp somewhere on the detail which says waterproofing to specialist details. So line on a drawing by architect engineer, waterproofing to specialist details, and we instantly jump to solution provision, which is saying use X product here, X product there, this particular additive, and that is in accordance with BS 8102, provides a grade 3 environment. So that is designing without understanding the appropriate risks. We see the same in BS 8485 with the point score system. We'll see details come into our office which say we have a CS2 residential housing development type A, 3.5 points required, and we go ventilated subfloor void, 150 mil minimum, 2.5 points, gas protective membrane, 2 points, 4.5 points, CS2 type A, tick, move on. That is not design. So adding up point score for particular elements is not design. You are basically ignoring the risk assessment. So again, what we're going to do is focus on what we would expect to see to be able to justify those solutions that we propose from a supplier, manufacturer, contracting point of view, as well as for the regulatory perspective, so building control architects, engineers, in terms of what information is required to provide that performance specification. Again, I'm going to try my best to cover it all, yeah? So we look at design flowcharts. So on the left-hand side, there is the design flowchart from BS 8102. On the right-hand side is the design flowchart from BS 8485. And in the middle is the combined flowchart from the TBIC document. And again, you're not supposed to be able to see that slide. They were designed to transition in individually, but the process of forming the design team, site investigation, desk study, risk assessment is consistent through all three approaches. So we should be doing that anyway. So we're going to remind ourselves of this process, which I think is important because we have definitely, in general, I know my mate, well, there's a few mates, in fact, I shouldn't mention them individually, and I've not checked the chat, but I can probably bet my house that there's probably 2 or 3 people who are already chirping saying we do that. Like, don't worry, we sort that out. BSA 102. So dealing with that combined gas and waterproofing system, I would argue it's already in there. So the design philosophy, so section 4.1 details that appropriate structural waterproofing design should account for things like contamination, radon protection, methane, carbon dioxide, and other contaminants in the ground. The risk assessment process is already detailed out. Then we have an options appraisal phase already in BS 8102 before we get to the solution phase. So the process of investigate the site, look at the risk, appraise the options, provide a solution is consistent throughout all this document. So that is the journey we are now about to embark on. So good risk assessment helps distinguish the high-risk sites from the low-risk sites. So it's very difficult to say a site is low risk unless you've completed an element of site investigation, desk study, or risk assessment. So external factors may need control, so things we can't do immediately in the vicinity of the structure. We may have to do some off-site measures to reduce the risk, and some developments may be completely unviable. So we although we ended up winning an award for it, like there was the Harper Road project at Coventry recently, which needed an off-site, so dewatering, contamination curtain wall to make the student flats viable. So that off-site process was an integral part of enabling that development to occur. There's another poll here. If Andy can start to prepare himself. I've chucked this in here because, again, it came up in discussion the other day. If we're looking at this sort of risk assessment design process, so who would normally complete that, do we think? So in our opinion, who is assessing this risk? Is it a waterproofing specialist or would it be a waterproofing designer?
Well, folks, the poll's now up for everyone. Again, similar process. Just leave it up for a couple of secs.
Again, don't let it run for too long. Just once the bulk of opinion starts to come through, just shout that out, Andy. But we debated this point the other day on Skype with some of my esteemed colleagues in the industry for 1 hour and 20 minutes. So let's take 10 seconds to see what the room quickly thinks.
Well, I can tell you there's a clear winner. The clear winner being waterproof designer at 78%.
Yeah, again, I think it's a tricky one because the waterproofing designer is probably towards the right answer. But if that waterproofing designer perhaps doesn't have the appropriate experience or knowledge in contaminated land or ground gas assessment, then they should recognise that limitation and seek to implement additional consultation onto the design team. So it's okay to make that suggestion. Like, I think we should get a specialist, a SOBRA or Silk, specialist in land contamination, involved in this particular project. Now, remember, we are focusing throughout the presentation on sites where there would be some level of gas, of course. If we can risk assess the site and say there is no requirements for gas protection or it's low risk, then you may not need to incorporate that additional support. But yeah, we need to recognise what we can and cannot do and engage appropriate specialisms where there are gaps in our knowledge. Otherwise, we would be taking on additional risk, which we'll come to right at the end in terms of limitations and being careful not to accept additional risk factors when not required. So the risk assessment process, I've stolen this from Neil Salvage, who stole it from Ground Gas Solutions, GGS. The pie chart of investigation, risk assessment, design, installation, the gap at the end is the check. So check, verification, did it work? But 60% approximately of the pie is upfront work, so investigate, risk assess, design. So a big chunk of the inception through to development and construction is planning. Yeah. Now, we talked about the JIT, just in time. If we reduce that 60% to 2%, 1%, then of course we're asking for trouble. Keep clicking the sign button. So again, another poll, and then I'm going to leave you alone for a little bit. Has anyone ever completed or reviewed a conceptual site model? So often abbreviated to the acronym CSM, conceptual site model, or a ground model, which is the BS 593 terminology. So have you run that poll, Andy? And I think what I'm trying to instigate with our own team is getting in the habit of just whipping out a piece of paper and sketching up the site and where potential risk factors may be coming from in terms of developing those basic ground models. It helps us understand it. But how many people have reviewed or completed, Andy?
Well, it's still there seems to be one clear winner, which the answer being no bloody chance, lad.
No bloody chance, lad. That I mean, and I accept that because conceptual site model is something we become very familiar with as a geologist. Obviously, I sort of weaned off university on ground models, so it's second nature for me. But it's not for everyone else. But a visual representation of the site and the risks, what is the source of potential contamination or the hazards, so water, gas contamination? How is it getting to the structure, so pathway? And then the receptor is obviously humans, animals, vegetation. So that source, pathway, receptor model, we can visually represent that with a conceptual site model. So here's an example of a conceptual site model straight out of BS 8485. So if we look at houses with semi-basements or full basements, and we're looking at where is potential contamination or hazard coming from, how is it getting to the development? Yeah, and once we begin to understand that, we can then look at ways at eliminating or reducing the risk. Yeah, so the building up that visual representation is an important step in the process. And I stole this from EPG. Actually, I got permission to do so, but EPG represents it very well when it comes to assessing structures below ground. The type of risk assessment is dependent a lot on the groundwater table. So whether we have water or a high water table, so water directly in contact with the basement, the assessment or the type of assessment is different. So that would primarily be a dissolved phase assessment. So the water has the gas in solution, and if the water is entering the structure, it's taking the gas into the structure. On the right-hand side, where you have a capillary zone or an unsaturated zone below the structure with a low water table or a water table which is variable, which has a pumping effect on ground gas, then the risk driver is gas. So gas will be forcing its way or looking to enter the structure in gaseous phase. So the two ways of assessing the risk are different depending on the groundwater table. So very, very deep basement structures, which would be anticipated to be completely submerged for most of the time, then a gas phase risk assessment is not the most appropriate way of assessing the gas risk on that structure. It's a more detailed dissolved phase assessment. Okay. Now, again, that in itself is probably a 3-day training course. So we'll very briefly touch on it, but it's the different ways to look at the risks and justify solutions ultimately. Yeah. So a desk study, so a good desk study is about technical due diligence. So we start at like a high level, so a helicopter view. So we're up in our choppers and we're looking at the site. And we're saying, what can we see around the site? Like, what's that over there? That looks like an old landfill site, or there's what looks like an abandoned factory over there. So there's a potential for some off-site source contamination over there. So we complete that over or high-level check first, and that will then determine whether we feel there is justification for doing any more investigative work, or whether we feel the desk study has provided enough information for us to justify the site is reasonably low risk and proceed as such. So the desk study may kick out the fact that we need a ground investigation. So we may need to dig some boreholes or trial pits, or what's called a phase 2 or a phase 2A, which is perhaps some bespoke gas monitoring or vapor assessments. And then usually on the back of an investigative report, there's a level of interpretation that occurs, so what's called a phase 3, where we investigate and we report, and then we interpret that. What does it mean? So what are the consequences of that? Additional remediation may be required to reduce the level of contamination to an acceptable measure, i.e. the incorporation of gas protective measures or the removal of on-site contamination by excavation. So we need to dig that source of contamination out, move it off-site, before we can proceed with the development. If we leave it in the ground, then we're going to have some very expensive and costly protective measures to implement. And then phase 4, which is validation or verification as we commonly know it. That's part of a phase 4. Recognized gas screening approaches. I'm going to just start to speed up a little bit. I'm nearly half past. So we have low risk sites which can work on total organic carbon content, TOC assessment, so made ground assessment, what we call semi-quantitative approach or empirical, which is the gas screening values or the CS scores and the matrix from BS 8485, and then what's referred to as DQRA, so detailed quantitative risk assessment. Now, a DQRA is usually required when the risks are either too high to model empirically, so when it comes to basement structure, it may be the points score model doesn't fit, given the risk. So we need to do a more detailed assessment, or we can use it to lower the risk or characterize the site in more detail. So we investigate the potential over time of the source. So it's any source of contaminant has to have the potential to remain over time to present a threat or a risk to human health. Yeah. So a DQRA will look at that in more detail. So then performance specifications, which are generally referred to as open. Open specifications, usually laid down by the designer, appraising options to mitigate proposed risks based on lines of evidence with suitable justifications. Or we have product specifications, which are also called closed specifications, where the designer may specify particular products through justification, or it's a proposal by installer, contractor, manufacturer offering products which perform application functions. So when we look at gas protection above ground, we have three elements to work with. So the structure itself, which can be various forms and has a sliding scale of points, but that sliding scale represents the relative impermeability to gas of the structure. So the more compact, dense, reinforced concrete will have a higher gas protection score versus open block and beam flooring, which is relatively leaky and therefore has no protective score. Gas membrane, so a 0 or 2 point score. External ventilation, again a sliding score based on the amount of air and the ability of the open void below the structure to dilute hazardous ground gas to an acceptable concentration. When it comes to basement construction, we generally discount external ventilation in respect of BS 8485 because we can't guarantee that the external ventilation is going to remain functionally intact, so i.e. the void remains open below the structure for the anticipated design service life, which is probably going to be at least 60 years, because the basement could, or the below ground structure, or that void below the below ground structure can flood. Yeah, and if it fills with water, then it's not allowing air to move through it. So we can't rely on those systems for below ground waterproofing and gas protection. So when it comes to BS 8102 and below ground structures, we're left with the type A protection, so externally or potentially internally applied in cases, barrier, the structure itself again, which is very, very important, and then an internal cavity drainage membrane. So we're looking at risk coming from the outside of the structure, working its way in towards the receptor. Just very quickly touching on retrospective basement, so we don't have the ability to look at the outside, so we're often forced to deal with the inside. So again, this new Syria document that's coming out will deal with this in much more detail, but your option appraisal is significantly reduced when you're looking at existing structures because you can't access all areas of construction. As we touched on before, so this, you may have come across this in risk assessment, so ERIC, or so ERIC PD it actually is. So the PD is protective equipment and detection. But if we focus on the core principle, eliminate, reduce, isolate, control. So the first thing we look to do with any sort of risk assessment is to eliminate and reduce the risk before we have to isolate and control it in contact with the receptor. So another poll for Andy to throw up. Just a question. I'll be surprised if anyone gets this one wrong, although there is no wrong answer, or is there? Where is the best place in new build construction to address risk? Yeah.
Well, folks, that poll is now up for everyone. It should again just pop up on your screen. I'm just waiting for results just coming through at the moment. Patrick, I can tell you there's one clear winner at the moment.
Inside. Well, wait, what?
There's one clear winner at the moment, but people are still pressing the button, so I'm not going to announce that answer just yet. So we'll give it another 3 or 4 seconds, guys, just to prevent it, because we need to kind of move on. So 3, 2, 1.
We're moving.
There we go. Right, okay, clear winner being Number one, before it comes
Outside.
into the structure.
Outside, yeah. So, I mean, I think it's an obvious one. So we should be looking to keep the risk out of the structure as best we can. And only if it's impossible to do that, should we start to implement isolation and control measures in close proximity to the receptor. So we're going to move through onto options appraisals now. So we look at the structure first. So probably the most important aspect of any construction is what it's going to be built out of. This is doing all the structural work. It's keeping the building up. It's keeping it intact, integral. So the structural aspect is the primary form of defence. Andy's messaging me, speed up. So you can build a structure out of anything. I mean, I put the plastic bottles one on there because I think it's amazing some of the things they do in developing countries, where we're looking at sort of different methods of construction to keep people safe and dry. But it's just completely inappropriate for below ground structures. When we look at BS 8485, I know there's a lot of people upset about this or can't quite understand it, and I am one of them. Why they decided to differentiate the point score between grade 2 and grade 3 waterproofing. I don't know many structural engineers that design the concrete to leak, which is essentially what design into grade 2 would be. We're usually looking at making the structure as watertight as possible. And therefore, so I think we should all accept a good or well QA'd, so quality assured, compacted concrete pour with controlled crack width is deemed sufficiently impervious to water and gas. So a well compacted concrete structure has a very, very low risk score when it comes to gas and water permeation, and therefore it has a high point score in terms of its point scoring index, so 2.5 points. What was clarified in 2019 because of the grading environment, which causes confusion as well sometimes, was that score is for the structure on its own. It's not dependent on the actual grade environment. So what we're actually looking to do is to remove that ambiguity. I don't think many people would be looking to use 2 points. Because 8485 further goes on, when we look at A6, so Appendix A6, A2, it actually classifies concrete to grade 2 or 3 to BS 8102, which is essentially BSEN 992, part 3, as low risk. Yeah. And then I stole this from the Concrete Centre as well. So we look at tightness class of concrete structures with regards to the water table. So if we start to look towards tightness classifications rather than grading environments with regards to gas protection, this may assist the process of understanding that well compacted, QA'd concrete is a good form of defence for water and gas protection. NHBC guidance goes as far to stipulate crack widths. So what NHBC would deem as watertight. Concrete with admixtures is 0.2 for cracks all the way through and 0.3 for flexural, and without admixtures 0.2 for both full and flexural cracks. The inclusion of an additive, an admixture, or a superplasticizer or crack inducer in injection, I don't want to exclude any potential solution here. That's not what it's about, because everything is on the table for consideration as long as appropriate justifications are in place. So if I've missed a particular technology you provide and you're in the chat and you're currently melting your keyboard, I apologise. I can amend retrospectively the presentation to include it if you feel appropriate. But the inclusion of these performance enhancing products, let's use that. Reduce pore space, conceal cracks, and promote healing and reduce capillary action of the concrete, which reduce the risk even further. So if we can improve the water tightness of the concrete, it will improve its resistance to gas transmission. So that is a risk reducer, the inclusion of a performance enhancing additive. But there is this argument that all concrete is porous. So notwithstanding it does crack, and gas, and particularly radon, will permeate through the pores and also by diffusion across the pores. So radon in particular, being a radioactive element, through decay from radium's alpha particle down to radon, can move across that concrete structure fairly readily. So if we're dealing with radon affected sites, and I know again I'm trying deliberately not to touch on that because it is its subject in its own right, you should incorporate some sort of protection or ventilation system internally to control that. Type A systems, there are a whole raft of protective measures out there. 8485 goes as far as this table 7, which again is the bane of most people's lives because everyone just focuses immediately on the benchmark performance value of less than 40 millilitres per metre squared per day per atmosphere, but there are other things to consider in there. Probably the most relevant part is the independent verification to C735. 8485 also confirms that there are many different types of gas membrane and membrane choices. So each type of membrane should be considered on its individual merits and conformance of properties. So the ability for it to resist puncture, elongate through anticipated structural movement, the gas transmission rate, its resistance to water pressure at various application depths are all things we should consider. And 8485, and one of the things we do like about 8485 is it encourages the use of qualified installers, because as we know, no matter how good these systems are, if they're installed like a bag of spanners, they won't work. The same is true of concrete, type A membranes. If we just let unqualified, unskilled labour install these systems, we're asking for trouble in the future. So there's a focus on do it properly, have it independently checked, and that is the best way of reducing scope for defects or potential defects to occur at some point in the future. Type A options in BS 8102 vary from loose laid bonded sheet membranes, liquid applied systems, GCLs, incorporating coated products as well, mastic asphalt, cementitious crystalline slurries on multi-core renders. And what you tend to find is the GTR increases as the pore space is open. So your barrier systems or membrane systems generally have a lower gas transmission rate, and your cementitious type systems have a higher gas transmission rate. Each of these systems can be justified as appropriate in any given risk scenario by the designer. It's not a pass or fail criteria. Everything has to be justified. It's easier to justify the inclusion of a material which has a low gas transmission rate than high, but everything should be considered. C748, again, hydrocarbons and VOCs, you're dealing with fairly bespoke vapor intrusion assessment. So the information is important. So if you're going to consider these materials for use as inclusion as VOC and hydrocarbon membranes, you would expect to see a set of information which is outlined in C748, and that is permeation rates for suite of BTECs, TCE, so tetrachloroethane, trichloroethane, hexane, vinyl chloride. It's like what we call the challenge 9. So as well as durability information, because hydrocarbons in particular are fairly aggressive on structures and on thermoplastic materials or derivatives of. So it's additional assessment required for VOCs and hydrocarbons. Aluminium foils below ground, again, I think, again, I'm just going to quickly touch on this. We're seeing quite a lot of this in the minute because we have above ground gas membranes, which are enhanced DPMs, so damp-proof membranes, usually incorporating a layer of aluminium, which has a very low transmission rate for gas. And we think if we stick a gas-resistant damp-proof membrane onto the back of a typical waterproofing product, then we've got a waterproofing membrane and we have a gas-proofing damp-proof membrane. We stick the two together, but that's a recipe for disaster. So the aluminium will will degrade over time. So aluminium is not designed to be installed in hydrostatic application conditions. It corrodes. On the negative side, it removes the bonding element, and on the positive side, it prevents the hydration of this active system. And I've just got enough time to squeeze it in. So Terminator 2 technology doesn't exist. So aluminium doesn't self-heal, contrary to what some marketing literature would have you believe. So massive red flag for me, that. Type Cs. So management systems allow, obviously, water into the structures. So for new build construction, Type C is, unfortunately, for probably a lot of the audience who are going to melt their keyboards at me in a minute, a last resort where gas protection is required. So BS 8485 goes as far as saying Type C systems may pose an unacceptably high risk on sites affected by ground gas. But don't despair, because where ground gas is on there, and we're looking at cavity drainage membranes or Type C systems, the ability of the CDM itself to restrict gas, so the GTR, is largely irrelevant. So what is important is that we can ventilate that void. So once the gas is in that void, where does it go? So we can do designs or systems which will excavate that void. So either by the addition or removal of air. I need to be really careful with my wording, because there's probably two particular individuals sat there waiting to press buttons. And radon will collect at lowest points. So those sumps, we must be able to ventilate those sump areas. You can't exceed the greenfield runoff rate. I scoured the internet high and low for a picture with a Celotex insulation board on, just FYI. Can't exceed the greenfield runoff rate. Contaminated water, which is collected in an ICD system where there is contamination and ground gas on site, requires a special discharge consent. So we can't just chuck that particularly into surface water. We need discharge consents or discharge permits, and then that information should form part of the O&M pack that is passed on to the owner occupier, who's responsible for the ongoing maintenance of those systems. So provided you do all that, then there is consideration for those systems, and hopefully you can all be happy again. Reducing risk with combined elements, and I'm going to speed up a little bit now, and is kicking me under the table. But we're beginning now to look at assessing products and suitability in the design setting. So we've completed that risk assessment process. We're going through the design flow. That's all we're doing. We're just going through the process. We're assessing the risk. We're looking at the options. What is the most suitable option? And then, that helps us define the scope of protective measures, including for elements of uncertainty, so factors of safety. So there are factors of safety built in to these empirical models that you will see that form the point score. So that's what DQRA will do as well. You basically start to look at reducing those partial factors. So your overall factor of safety may come down, which means that protective measures may be able to be justified for higher risk sites. And we've also got to give that due consideration to feasibility of ongoing maintenance and repair work should defects present. That is consideration in all designs, not just waterproofing. So a typical specification that may come out would not, for me, not state a product. And I know a lot of people are going to be like, well, you're crazy. And my own commercial team thinks I'm mental when I do this. But open specification. So if you are a specifier and you name a product, then I don't use this to scare you, but that's what happened at Grenfell. So they specified a product which was hiding information. So you're almost better keeping it open and letting market do the cost saving for you. So they will compete to offer then more competitive value engineered solutions to hit the performance specification. So you would get typical performance requirements for the Type A, Type B, or Type C system, and then it's up to us as suppliers, contractors, manufacturers to make the system fit the performance specification. Durability, we're coming towards the end here. Something we always miss, and again, we run separate CPDs on this element on its own. So materials that are used in the built environment, have an anticipated design service life of at least 60 years where they're forming critical material functions. So things like damp proofing and waterproofing is deemed a critical barrier function, which means the anticipated design service life of the materials we use should be at least 60 years. Yeah. So when we use the word sustainable, immediately the end user thinks you're using some sort of recycled raw material. So, and there's a conflict of interest here because raw material for critical performance barriers should be controlled, which means virgin to a specification. Where you introduced a recycled element, you vary the raw material, which compromises its performance over time, which could potentially compromise its application function in the built environment. In terms of contractors' liability, and we're coming to the end here, just a couple more slides before I dare to check the chat and see what sort of questions we're looking at. Ask for this information. So where is the site investigation report? Yeah, what is the risk? What am I dealing with? Is there a remediation method statement? Has there been any ground gas vapor risk assessments completed? What is the performance specification for gas and waterproofing? Is there a verification plan we're looking to follow that's been produced as part of the design? And without that, anything you offer is deemed to have been assessed as suitable. So you open yourself up to quite a lot of liability if you don't review this information. And don't be afraid to put those limitations in your project submissions or design reports or technical assessments, whatever you want to call it. List the information sources, list what recommendations you're not covering because you don't have the relevant information, and provide the justifications for any proposals you do make, and try not to avoid or try not to alter that performance specification, because that is where you start to adopt design responsibility. So if the performance specification is based on let's say a concrete with a type 1 classification, I'll pick on concrete because they're big boys, and you alter that and say, well, you could reduce the structural element by incorporating this particular product. That is a huge shift in a performance specification, and so there's a lot of liability associated with doing that. Top tips, Andy loves his top tips from PCA/Andy and Paddy. Engage appropriate specialisms early, so get the relevant people involved as early as possible. Information, so site investigation, that information is king. Having that information enables us to reduce risk and risk exposure across the supply chain. Be conservative unless you can robustly justify the deviation from standards or performance specification. And durability. Let's look at how long these products are going to perform this application function. I thank you very much for your time. I'm going to check the chat while Andy comes back in and does his thing.
That almost rhymes. That's his thing. Well, yeah, many thanks, Patrick, for that presentation. I have to say, there seems to be quite a lot of love for your shirts. I have never in my life had an email before commenting on people's shirts before, plus some comments in the comments functionality as well, just for everyone's benefit. What is actually on your shirts? Is it reindeer?
There's all sorts on it. So reindeers, Christmas trees, some snowflakes, bells. Yeah, I don't know. It's like a general festive shirt. And again, I see my mate Peter Hatch, big up Peter Hatch, commenting there. I know Peter and I have a competition about who can wear the most garish jumper and shirt. So no pressure, Peter. Next time I see him, I hope he's wearing something ridiculously garish.
Wow, very much down for you. But I have to say, Patrick, there's been quite a bit of debate of your first poll, one which takes precedence, BS 8102 or BS 8485 plus your A1 2019. I will leave you to have a look at the chat a little bit later on, but I think there's a little bit of controversy in there, and feel free if anyone wants to kind of comment any further on that. But without further ado, because I am conscious of time, I am going to jump on to questions at the moment. Sorry, I'm just trying to get myself just sorted.
Yeah, sorry, Andy. I'm just trying to keep up with the chat there, but I think there's a lot of people sort of still commenting. It keeps moving, so I'm going to give up trying to do that and let you moderate and check for me. Yeah?
Yes, you do that. But your first question comes from Peter Henderson. Does a basement constructed with reinforced concrete to BS 8102 standards with a membrane also used attract 4.5 points? I don't understand what the points bit is, but hopefully you'll explain out.
Yeah, so I understand where Peter's coming from. So I think if you've got well compacted QA'd reinforced concrete designed to BSEN 992 Part 3, then in terms of the point scoring system, so if we're looking at the empirical model, that will be 2.5 points of protective effort. And then if we've got a suitably gas-resistant membrane, sufficiently durable, sufficiently robust, capable of surviving the installation process and the ongoing service stress of the building, it's independently verified to C735. That will be attributed an additional 2 points. So the combined system of AB, there will be 4.5 points based on that empirical model, yeah?
Oh, no, because I just noticed that Ian Price has just stuck up a comment there, and I think it maybe things in well with what you've said. Would you agree that the concrete and membrane should be considered together in GTR calculations then?
Yeah, completely. And Ian knows my thoughts on this. So that is part of a DQRA, so a detailed qualitative risk assessment. You can consider the membrane element and the concrete as a composite and calculate the gas transmission through there, but you're not looking to define a GTR essentially, Ian. What you're doing is saying, I've got hazardous gas concentration on the outside of the structure of, let's say, 100%, and my Environmental Protection Act Part 2A says the acceptable level for receptors is for methane 1%. So I've got to take the 100% down to 1% using a membrane and the concrete. I know the permeability or gas transmission of the membrane. I know the permeability and gas transmission of a well-compacted concrete that won't crack. I'll run a risk assessment and look at partial diffusion coefficients through the composite system. I'll then sensitivity check that by inducing cracks and looking at joints. And then I will make a judgment call, so a professional judgment call, as to whether that system is suitably impervious to gas to reduce the risk across the system. So it's not about defining a GTR for that system. That is part of this DQRA process, Ian.
Okay. Well, yeah, Patrick, I've got a couple of questions. If you can, try make the answer short just for these ones. But Nick,
sorry.
Comes from Vikram. Vikram, sorry, I don't quite know how to pronounce your surname, but he's asking, would a grade-free basement be sufficient to provide ground gas protection by default?
Potentially, yes.
Okay, well, that is as short as you can get it.
Andy did say short, but grade 3 is actually a conditional environment. So I don't like the use of the grading score for protection. But if you are able to provide, by justification, a dry environment internally, then yes, there is justification that would reduce the gas risk. But you must understand the risk and be able to demonstrate that. And that's what it's always about. It's not about just saying, well, my system provides a grade 3 environment and therefore it's gas resistant. You have to justify that. Well, why? Because if I say to you why, and you're like, well, because it's dry inside, that's not enough. You have to say, here's the diffusion calculations through the system. On that particular site, the risk is an elevated methane concentration, for example, of 12%. So we're looking to go from 12 on the outside to 1 on the inside. Here's the relevant calculation to justify that our system achieves that.
Well, I want to say to you this, Martin Freeman is very much in disagreement to you. So that's maybe a wee chat you and Martin can have a wee chat back and forth on. But here, moving on to the next question.
I can't see that one.
I might say, no, Martin, here, I am more than open. We're an open forum, so please do expand on your point and we can maybe hopefully have a wee chat on it. And next question. Next question is a private question that's been sent to me. What is your view on liquid applied membranes for gas protection, including the difficulty in managing application thickness on site?
Yeah, no, it's really good actually. I was talking to NHBC about this the other day, and it's a fair point. I think liquid applied systems, there are some on the market which have information to allow us to assess the products, because again, that's important. If we're proposing the use of a liquid applied system as a gas membrane, then we would expect to see some information to be able to make a justifiable assessment. So things like a gas transmission rate to ISO 15105 part 1, manometrics or pressure applied. If we have that information based on a minimum application thickness, then what we tend to do is say go for, like if it's a 1 mil applied system, 2 coats, put 2 coats on at 0.6, so you've got a 20% over factor built in, or over application factor, and then you can spot check it. And I mean, there's a couple of verifiers in the chat. I've seen this. I know a couple of them have laser spot checkers, but yeah, for me, the verification of that system should be a controlled panel. So you would have a panel layout, effectively like a grid. That you would create in terms of assessment, and then you spot check the thickness on an agreed grid, of which is normally going to be somewhere between 0.3 and 0.5 meters wide. So then you would do a fairly detailed thickness check to make sure you were happy there was no areas which potentially compromised in terms of thickness. Sorry, Andy, I'm trying my best.
It sounds. For those, I'm not. So I'm kind of sucking this up, but it sounds terribly complicated, terribly difficult to get it right. Yeah,
if you don't understand it, I think, and that's the point, what we're doing as an industry now, I think we've got, which is lovely to see, you have these sort of, not really opposing industries, but industries which have traditionally run separately, all of a sudden clashing together, and we're all trying to understand each other, the different ways we do things, and how we can all improve together. And I think, you know, we will be able to do that, but we're going to have to let go of some of the old ways of doing things. And I think that's an important thing to understand.
Well, I think Tom Thornton just said it nicely. It's a big subject, and it's probably too much to talk about here. That's maybe a subject for another future webinar. I'm only going to hit you with 2 more questions here because we are severely running out of time. Folks, my apologies. We might be a couple of minutes over. But next question comes from Lee Clow. Based on the recent Celotex findings that was mentioned earlier, do you think more clarity should be given for a membrane that meets ISO 15105/1? Bloody hell, what is it with names in this industry? 15105-1. Hopefully you got the gist of that.
Yeah, I understand, and I think Lee's point, I guess, is in reference to the achieving the performance standard, and I think it's not a pass or fail. It's a what's the information. You know, of course, people will market it as a should be this, should be that, and I guess, you know, the intention of BS 8485 when they placed benchmark values on permeation rates and materials was because above ground a lot of the performance is in the membrane. So you're dealing with leaky flow construction, sometimes void below the slab where gas can accumulate, so the membrane or its ability to prevent gas transmission is more critical, whereas in the ground, below ground, more robust membranes are required. So it's a combination of things. I don't think we can just rely on ISO 15105 part 1.
Okay, well, I did say 2 more questions, but there is 2 questions I do want to raise. And again, if you can make them quick answers. First one from Rob Dolman. Shouldn't verifiers take more responsibility when signing off gas membrane installations? This could be.
Yeah, I mean, the verifier plays a very important part in the process. So the verifier is the check. It's the final check, effectively. And I think they're taking quite a lot of responsibility as they are at the minute. whether they should take more, I don't know. That's probably a question for the verifiers. They would probably argue they're taking enough. Once they sign something off and take a portion of liability with signing off these systems, that's a fair chunk of responsibility anyway. But yeah, I mean, I know Rob very well, so if Rob wants to talk to me offline about that in more detail, that's fine, Andy.
Well, there you go, Rob. You've got the invite there. Lastly, but not least, and this just comes off the back of a point of a comment or comment on one of the polls. One of your polls that you ran, which was who assesses the risk on site, waterproof designer or waterproofing specialist? So come back in terms of, well, what about gas-related knowledge? What gas-related knowledge do they actually have, and how can they assess joint risk?
No, that was my point. I think when we feel comfortable with waterproofing, but we don't know about gas. So there's nothing wrong with saying, like, I feel as part of the design team we should get a specialist involved here. So there are recognised qualifications in there. So in terms of contaminated land assessment, so you have the ASOBRA scheme. So these are brownfield professionals, or the SILK, which is a specialist in land contamination assessment. So you could always make that suggestion. Similarly, a lot of those guys will have specialisms in waterproofing, but the formation of the design team and having the appropriate experience to assess the risk is an important part of any development process. Yeah.
Okay. Well, Patrick, firstly, guys, everyone, many thanks for your questions. If we didn't get round to answering your question, I do apologise, but I will ping them over to Patrick, and hopefully he might be able to kind of get back to you. Just kind of rounding some stuff off. There is some sources of additional information. You heard Patrick mention some of the sources earlier on. The Syria document is coming out soon. There's some new documents coming out from the Concrete Centre as well, which I know that Patrick has been jointly working on, but there is other areas where you can get more information. There are, both for our ground gas specialist and for our structural waterproofing specialist, there is document libraries there. Links are on the screen, but we also have a whole host of professional guidance and additional information that you can gain access to just via the professional sections of the PCA website, and you can see the link on screen there. Of course, and as always, this webinar will be available for sharing out as of at some point tomorrow. I just want to kind of touch on and this is more for our ground gas specialists. You heard me mention it earlier on in the webinar. If you didn't, over the last 2 years, the PCA has been effectively the sole administrator for the Level 4 MVQ diploma in the verification of ground gas protection systems. We're really pleased, after a lot of going back and forth, that over the last few weeks, the CSCS, the Construction Safety Certificate Scheme, have now actually recognised this qualification. So it's effectively an extra feather to your cap if you actually have this qualification. Now, if you do want more information about it, please do contact our training team. And there is also some other supporting training courses and stuff like that that you can go on to as well. In terms of next webinars, well, that is us until 2021. That's the reason why as well Patrick wore a festive shirt, and technically I should have worn a festive shirt as well, but our webinars will be back at the end of January in 2021 and back on a monthly basis. But as always, you can access all the webinars that we have had over the last 12 months just via the link. Lastly but not least, I just want to say a big thank you to Patrick from Utah for coming on board and taking this challenging, and it was a challenging presentation, and sharing your knowledge with all of us, Patrick. I'd like to say a big thank you to our audience out there as well for joining us over the last 12 months. Hopefully we will see you back in 2021, and if you do have any suggestions in terms of webinars, please do get it over to us. But without further ado, it's a goodbye from myself. It's a goodbye from Patrick, and we hope to see you next year. Take care, everyone.
Thanks, guys. Take care.